All right, welcome to this page of the notes. And what we're going to do is we're now going to begin to look at what happens to these exponential growth functions as we begin to perform transformations on them. That means as the constants a, h, and k begin to change. Real quick, the parent function, which is a term you guys are familiar with from back in chapter 2, the graph of f of x equals b to the x represents the graph of the exponential parent function, or is the parent graph of the exponential function. But what we want to do is begin to talk about, okay, what are the transformations? Well, I give you the general formula right here at the top of this table, where I then go through what does h do, what does k do, and what does a do. But we've been doing transformations in every chapter here in Algebra 2. You should be very familiar with them. If you've forgotten anything about a, h, and k, just jump on back to chapter 2 of Algebra 2, and we go through all of those in much, much greater detail. But just real quickly, h is going to be the horizontal transformation. It'll shift your graph left or right. The thing to remember about h is it's the opposite. If you have a positive h, your graph will actually shift in the negative direction. And if your h is a negative number, your graph will shift in the positive direction. It's the only one that's weird like that. K is going to be the vertical shift. It's up and down, and it's just whatever the number is, right? If your k is a positive number, you'll shift up, and if your k is a negative number, you'll shift down. A, the value of a, the constant a, actually does two things. If a is positive, your graph will open above the x-axis. If a is negative, your graph will flip across the x-axis. It's a reflection. It will open below the x-axis, so we'll want to watch out for that with a. But then a also determines the vertical stretch or compression. And what we mean by that is we actually mean stretching the graph. It'll make your exponential function grow much steeper, or if it's a vertical compression, it'll make your exponential function much shallower. And we'll take a look at all of those as we go through some example problems. What I want to point out to you is this: as always, you'll find a out front, right? It'll be some number in front of your exponential base. You'll see here in a second when we do some example problems, but a will just be a number tacked on out front. The value of h will always be in the exponential position. It'll be raised as part of the exponent along with your variable. So it'll be very, very easy to find h. It'll always be up there in the exponent position. And then k, again, as always, will just be some number tacked on to the end of the function. Let's jump right into these and go ahead and take a look at a couple of example problems, and you'll pick it up real quick if you've forgotten any of this as we go through it. We're going to start off by taking a look at one without transformation. So this is another one, exponential function. I know it's exponential growth because my base is 2. I don't have an a. There's nothing out front. There's no number out front. I don't have an h because the x is all by itself in the exponent, and I don't have a number tacked on the end. There's no k. So we'll go ahead and write these down since we're doing transformations. Y equals a, b to the x plus h, plus or minus h, plus or minus k. And what I notice again is there's nothing out front. I just have my b. There is no h in the exponent position. There's nothing tacked on the end. So I know that a is equal to 1, h is equal to 0, and k is equal to 0. What that means is I have no transformations. So I know my graph is going to go through the point 0, 1. I know that my graph is going to have a horizontal asymptote, that's the x-axis, and I know that my graph is going to increase from left to right because there's no transformations. Let's go ahead and pick some x, y values. Go ahead and pick some domain values, x values, to plug into the function and see how this is going to go. I'll use the exact same ones I've been using. -3, -2, -1, 0, 1, 2, and 3 will be some good ones to go ahead and get us started. Use your calculator to do 2 raised to the negative third power, and you wind up with 0.125. If I do 2 raised to the negative second power, I get 0.25. 2 raised to the negative first is going to be 0.5. Use 0, so 2 raised to the 0 power. Anything to the 0 power is just a 1, so there's that point I told you would always show up as long as there's no transformations. There it is, 0, 1. 2 to the first power is just going to be a 2. 2 to the second power is 4, and 2 to the third power is 8. Let's go ahead and graph some of these points and see what we get. These ones will be pretty easy to graph. I think I can get those ones. There's negative 1.5, 0.2, somewhere right about there. There's my 0, 1, 2, 4, and 3, 8. All right, great. So I just was able to plot actually all of the points except for that bottom one. And not that I can't graph that top one, it's just that decimal is really tiny. It would be so close to the x-axis, but you know what the heck, we'll squeeze it in there somewhere right around there. Right about there. So anyway, what we'll do is we'll go ahead and connect those dots with a smooth curve. Remember, extend your line all the way through the coordinate plane, put arrows on both ends so I know you know that that graph just keeps going. And the x-axis will be my horizontal asymptote. And like I just said, because there's no transformations, I know it's going to increase from left to right, which is exactly what it does. So there you go. There's your graph. Sorry, I got a little stray mark in there. Get rid of it. There it goes. So there's my graph. And I do ask you for the domain and range, so let's go ahead and do that. But it's actually really easy. It's actually exactly the same as the previous two example problems that we did. The domain's going to be all real numbers. You can pick any value of x you want to and plug it in. It'll work. The range, again, because the x-axis is my horizontal asymptote, it'll be all values greater it'll be all values of y greater than 0. And again, that's just because the x-axis is my horizontal asymptote, which is a line that my graph will approach but never touch. All right, let's go ahead and do another one. This time, though, we'll actually have some transformations. So here on the next page, I've got this function for you, and we're going to go ahead and graph this guy. So right away, I'm going to remember that my general equation is y equals a times b raised to the x plus or minus h plus or minus k. And I go ahead and take a look at what I've been given, and I recognize, well, I don't have anything in front of my base, which in this case is a 2, so I don't have, well, I have an a, but it's just a positive 1, so there's no transformation there. If I had an h, it'd be up in the exponent position with the x, but I don't, so that means that my h is also a 0. And if I had a k, it'd be tacked on the end, and I do have a k. It's a plus 1. So here's what I know. I know now, just taking a look at this based on transformations, that my graph is going to be shifted up 1 unit. What that tells me is that my horizontal asymptote, which used to be the x-axis, is now going to be shifted up 1 unit, and I'm now going to have a horizontal asymptote of y equals a positive 1. So I'll go ahead and put a little dotted line in there, right there. That's going to be my new horizontal asymptote because my whole graph is going to get shifted up 1 unit thanks to k. Okay, let's go ahead and set up our chart, choose some domain values to plug in to get our range values back. I'll use the exact same ones I've been using. They're good, they're easy, no need to change now. I plug a -3 in for x, 2 to the -3rd, then add 1. If you do that, you get 1.125. Keep going. I do 2 raised to the -2nd power plus 1. You get 1.25. Do a -1, 2 to the -1st plus 1 is going to be 1.5. Now, the point, when I plugged in a 0, 2 to the 0 gives me a 1. So I used to have the point 0, 1. But the whole graph got shifted up 1 unit, which means that point 0, 1 now gets moved up a unit to 0, 2, which is exactly what you would find. You plug a 0 in here, 2 to the 0 power is 1, and 1 plus 1 is 2. So that point that was at 0, 1 has now been shifted up 1 unit to 0, 2. That should make perfect sense. The whole graph has been shifted up 1 unit. 2 to the 1st is 2, and 2 plus 1 is 3. 2 to the 2nd is 4, and 4 plus 1 is 5. 2 to the 3rd is 8. 8 plus 1 is 9. Let's go ahead and graph those points. Let's see, I got a couple more here, there, there, probably right about there. All right, so there we go. I'm just graphing all the points that I found in my table. And like we said, it looks almost exactly like the last graph, right? It looks almost identical to this one. The only difference is I have a transformation. I've shifted the whole thing up 1 unit because I have a value of 1 for k. We go ahead and graph this guy by drawing a smooth curve through there. Make sure you extend your line all the way through the coordinate plane. Put arrows on both ends so I know you know that that graph just keeps going. And now let's talk about the domain and range. Well, again, the domain has not changed. You can pick any value of x that you want to. It's going to be all real numbers. But the range is now going to be different. Please notice my horizontal asymptote has shifted up 1 unit thanks to k. So now my range is no longer all values of y greater than 0 because now my horizontal asymptote has shifted up a unit. So what I'll now need to do is I need a range that is all values of y greater than 1, which is my new horizontal asymptote. All values of y greater than 1. Right? Hopefully that makes sense as far as the domain and range goes, and the transformations are really pretty simple as long as you know the general form which I gave you on the previous page of the notes. Let's go ahead and do another one and see what we wind up with here. Again, the general equation is y equals a times b to the x plus or minus h plus or minus k. All right, well, I take a look at this and I recognize right away, hey, I do have a number in front of my base, which is 2. So that means I do have an a. My a is going to be equal to a negative 1/2. Now let's talk about what that means. First of all, please notice that the a is negative. What is now going to happen is I'm going to have a reflection across the x-axis. Instead of my graph opening up, my graph is now going to be flipped over the x-axis and open down below the x-axis. So that's what the negative sign does. And then the fact that a is a 1/2. Now remember, if a, that value of a, is something bigger than 1, it's going to be a vertical stretch. It means the slope of the graph is going to be steeper, right? But I have an a that's a fraction. It's less than 1, which is going to be a vertical compression. And so my exponential function is going to open below the x-axis, but it's going to be a real shallow, it'll have a shallow slope to it. So we'll see what that looks like when we graph it. Again, also I take another look at this and I go, well, if I have an h, it'll be up in the exponent with the x. And there is. I have x minus 2, so I know that my h is a negative 2. And of course, what that means if I have a negative 2 is it's going to be the opposite, right? So because h is a negative 2, I'm going to have to shift in the positive direction 2 units. I don't have a k because there's nothing out back there, and so k is just going to be equal to 0. Let's go ahead and set up a table. All right, now here's what I want to do. I know that my whole graph has been shifted to the right. Positive, because h is negative, I go the opposite direction, 2 units to the right. So instead of using negative 3, negative 2, negative 1, I'm going to shift my table by 2 units as well. So instead of starting at negative 3, I'm going to start at negative 1, right? I'll just shift over 2 units. That way I get data points that I'll actually be able to graph. Negative 1, 0, 1, 2, 3. I normally stopped my table at positive 3. I'll go 2 units past that, 4 and 5. All right, thanks to my value of h, I just shift my table as well because h has shifted my graph over. Again, we're just going to use our calculator to go ahead and do this. I'll plug in negative 1 in for x. Negative 1 minus 2 would be a minus 3. So you're going to do 2 to the negative 3rd power. Whatever that is, multiply it by a negative 1/2. I wind up with, actually here I apologize, I'm going to have to erase those real quick because they're kind of the long decimals. For negative 1, I wind up with 0.0, I'm sorry, hold up, I apologize. It's a negative number because I'm below the x-axis. Negative 0.0625. If you plug in a 0, you should wind up with negative 0.125. If you plug in a 1, you should wind up with negative 0.25. If you plug in a 2, I wind up with negative 0.5. If you plug in a 3, I get a negative 1. Plug in 4, I get a negative 2. Plug in a 5, I get a negative 4. Anyway, that should be more than enough points to go ahead and graph this function. Again, what you're doing is just make sure that you do the order of operations properly when you're plugging these into your calculator. Again, the way it works is if I were to do, x equals 2, I plug a 2 in here. 2 minus 2 is 0, right? So I'm actually going to have 2 raised to the 0 power, which I know is 1. Anything to the 0 power is 1. 1 times a negative 1/2 is a negative 1/2, which is why I wind up with 2 negative 1/2, right? So just make sure you use the order of operations correctly. Your calculator is a wonderful tool, but it's possible for you to tell it to do the wrong thing, so don't do that. All right, let's go ahead and graph the ones of these that I can. I can definitely do positive 2, negative 1/2, that's easy. Negative 1.25, that's pretty easy as well. The rest of those are kind of small decimals, but I know they're really, really close to the x-axis. The other ones are pretty easy. Negative 3, negative 1, that's no problem. 4, negative 2, no problem. 5, negative 4. All right, I think I've got a pretty good idea of what that guy's going to look like. So we'll just come right along here and drop this guy off right through there. Make sure that you extend your line all the way through the coordinate plane. Put arrows on both ends so I know you know that graph just keeps going. And it did exactly what we said it was going to do. I knew because my A was negative, it would have to be below the x-axis. I knew because my A was a 1/2, it was going to be compressed, so it doesn't take off quite as sharply. It's a little shallower slope. And again, I just fill out my chart to get some data points to plot. Let's go ahead and get the domain and range. And again, for this one, you can plug in any value of x that you want to. So it's going to be all real numbers. And as far as the range goes, please notice the x-axis once again is my horizontal asymptote. But instead of opening above the x-axis, I now open below the x-axis. So my range is going to be all values of y that are strictly less than 0, since my graph is below the x-axis and the x-axis serves as my horizontal asymptote. I have a couple more problems where we'll deal with transformations on the next page of the notes. So flip on over and I'll meet you guys there.